So what is particle technology? It refers to as a science and technology that is relating to the handling and processing of particles and powders. So as what I have mentioned last time during our orientation, uh, basically we will focus on the ways of handling particles. And to do that is we have to understand the properties or how particles behave, no, if they are to be processed using this particular operation and so on and so forth. So this particle technology applies to the production, handling, modification, and use of different particulate materials, both wet and dry. So pwede wet or pwede sad nga dry particles, okay? So when we say particles, these are referred to as bulk solids, or it could be particulate solids, or it could be also granular solids. So bali, it simply differs into the sizes. Okay? So pwede gamay kaayo or pwede dako-dako or granular or medium size. Basta when we say particles, we are referring to the solid phase, no, of matter. And these solids used in chemical industries are most commonly in the form of particles. So in process industries, solid appear in a variety of different forms. So naay mga solids na hard and abrasive. So meaning to say nga it can easily cut other materials. So you have to be very careful in handling those type of particles. And there are also particles that are tough and rubbery, while others are soft and fragile. Okay, so again, we have to be very careful in handling them because of the fragility of such material, while others are dusty and cohesive, and others are free-flowing or sticky, no? So lain-lain gud siya og mga properties, okay? So particularly in materials, either powders or bulk solids are used widely in all areas of the process industries. So daghan siya og applications, no? Like in the food processing, pharmaceuticals, biotechnology, oil, chemical, mineral processing, metallurgical, detergent, then powder generation, paint, plastics, and cosmetics industries. So these are just a few, no, of the industries that are using particulate materials or solid particles in their processes. So the knowledge of their properties, handling, storage, transportation, separation, and processing is important from the chemical engineering point of view. Okay. So what are the subjects included in particle technology? Okay, it includes the behavior of solids in bulk, including soil mechanics, the bulk material handling, silos, conveying, powder metallurgy, as well as nanotechnology. So apil ang nanotechnology. And then another subject that is included in particle technology is, of course, size reduction. That is, if we want to reduce the size of a particle, then we can use crushing and grinding operation. Or in the opposite, in another way around, we can also increase the size, no, of a particle. That is using flocculation, granulation. Flocculation is we add something like a chemical solution into that fluid, and then it will form flocks, no? Then granulation, powder compaction, tableting, and then crystallization. Okay, so that's those are the processes and operations that are used in increasing the size of particles. We can also separate particles using some separation operations such as sieving, uh, using sa sieving, mo ni siyang katong screening no process, and then tabling, flotation process. So in the flotation process, we separate particles by introducing something that will create bubbles. So mo tong ang bubbles mo na mo carry sa imong solid particles that will float no, on the surface of the fluid. Or it could be using magnetic separation and or electrostatic precipitation, and then fluidization, centrifugal separation, and liquid filtration. Okay. And of course, it includes the analytical procedures or steps, no? Like when we analyze the particle sizes, then we have to introduce these procedures, analytical procedures. So more or less, mo na siya ang topics that will be included in the particle technology. So that's why if you try to look at the course guide or the syllabus, you can find all these subjects being mentioned. So to characterize particles, they are usually characterized in terms of composition, the size, as well as the shape. So that's how we characterize particulates or particles. No, so in terms of composition, of course, no, because we want to know the content or what is the composition of such particle, and through that we can determine the density as well as conductivity. Okay, and then another property that we have to know is the size of the particle, because as what I have mentioned last time, that particle size is very crucial, no, in the industry, because yeah, there are many reasons why, you know, it's very important to know the particle size. Later on, you will know. And then, of course, the shape, whether uh, it is regular or irregular. So when I say regular, you can easily describe the shape of the particle. No? Irregular is we do not know how to describe the shape of that particle. No? Okay. But then we will simply focus on the particle size first. The particle size, or yeah, the particle size, there are many ways of determining the size, no? But when you say shape of a particle, katatong mention ganina nga, it's either regular siya or irregular, or in general, we describe the shape of a particle through its sphericity. Sphericity, we use the symbol, saan na siya nga symbol, psi na, no? Siya nga symbol. Okay, but anyway, sphericity is the surface area of sphere of the same volume as particle divided by the surface area of the particle. So you might be wondering how to compute for the sphericity. You need to know the surface area of a sphere as well as the surface area of the particle. Okay? So, unsa man siyang sphere, so later on, ma-explain ni siya. So, the sphericity, through the value of sphericity of a particle, then you can determine the shape of that particle. Like, for example, if the sphericity has a value of 1, then it follows that the shape of the particle is spherical, you know? Or if the value of sphericity is, for example, kung 0.6 baron, then the particle, the shape of the particle is a cuboid, something like that. So doon na siya specific nung shape for a specific value of sphericity. So later on, no, you will encounter that. But for non-spherical particle, this is defined through this formula. Saan siya nga symbol? That is P, no? P is equal to 6 times the volume of one particle divided by the equivalent diameter of the particle and the surface area of one particle. So that's another way of expressing, you know, aside from sphericity, we can also use this formula, most especially if they are non-spherical or the particle is non-spherical. Okay. So from that, we go back from this formula, natay D sub P diha, which is the equivalent diameter of particle. Now, what do you mean by equivalent diameter of a particle? Equivalent diameter, this is defined as the diameter of a sphere of equal volume. So meaning to say nga, you equate the volume of a particle with the volume of a sphere. So imo na siyang equate niya ang volume of the particle and the volume of a sphere. And then from there, you can compute for the diameter of the sphere, which also more or less, rather, that is the equivalent diameter. So you simply equate the volume of the sphere with the volume of the particle. Yeah, from there, you can compute for the equivalent diameter. So muna gimi niya nga equivalent diameter. So for fine particles, D sub P, ito na siyang D sub P, that is the equivalent diameter. This is usually taken to be the nominal size based on screed analysis or using microscopic analysis. So it refers to the nominal size if you are using the method of screening or the method of microscopy, or that is using microscope. The surface area is found from adsorption measurements or from the pressure drop in the bed of particles. So kani siya adsorption measurement is lain sa na siya nga technique in knowing the particle size, and then the other one is kani siyang pressure drop in a bed of particles. This is also another technique. But for many crush materials, usually sphericity is between 0.6 and 0.8. Kung gi-crush na siya nga material. And then for particles surrounded by abrasion, sphericity may reach as high as 0.95. Okay. So muna siya ang mga values, common values that they have found out if the sizes of particles are into this much na. So you have their particular value of the sphericity. Okay, so let's proceed to the particle size. As what we have mentioned, that the most important physical property is the particle size. And yeah, this is very rather common to most of the industries. No? Usually, ang particle size gid ang ilahang ginakuha ng very important specification. And this is often critical parameter in the manufacturing of many products. And it's because the particle size can influence some material properties. Like the particle size, maka-influence na siya sa reactivity or dissolution rate. Like unsa siya kapaspas ma-dissolve or unsa siya kadugay ma-dissolve, and so on and so forth, no? And it can also influence the stability in suspension, more especially for kanang sa pharmaceuticals, say you have an antibiotic or steroids, usually in suspended form na sila. So if there is solid particles found on that particular medicine, then mo na i-compute siya ang stability. Stable, how stable is the particle inside or within that suspension nga makastay siya, dili ba for how long siya na stable. Okay, so the particle size will will dictate the stability na kung if you are to use this particular size, like kung dagko siya or coarse type or coarse nga size particle, then for how long siya nga dili mo dissolve, something like that, no? So stability can affect the particle size. Another one is that the particle size can influence also the efficiency of delivery. Like for example, butang diha asthma inhalers. So dapat the asthma inhaler should have the right size of the particles inside, no? Or else kung dili siya the correct size of particles, then it cannot deliver, no? Walay ma-inhale ng medicine the person who is using the inhaler. So it will affect the efficiency of delivery. Another one is that particle size can also influence the texture, no? The texture, how usually sample ng food ingredients, okay? The texture and the feel. Di ba siya di ba rough or di ba siya smooth kaayo? So something like that. So it will affect also the texture and the feel. Another one is it has influence also in the appearance. Okay, like for example, powder coatings and inks, no? Okay, so sa imong inks diha, well, the particle size can affect in terms of physical appearance lang siya. Ay lain man sad og sobra sad kadako, no, ang imong particle size inside the ink solution, no? So it should be of the right size. Another one is that the particle size can influence the flowability and handling. Okay. Well, that it also depends, no? If you are using the right size of the particles, then it can easily be handled, okay? Or it could be we need to increase or enlarge the size of the particle because it would be very difficult to handle if the particle is very, very tiny, something like that. The other one is the viscosity. Okay, more or less, the example is the same as that nasal sprays, the viscosity. So, unsa siya ka diluted or concentrated. And then the last one, it can also influence the packing density and the porosity, like in some materials like ceramics. Okay. So these are the some of the material properties that can influence or can be influenced through the right particle size. So that's why it's very crucial to have the right particle size. So in general, diameter may be specified for any equidimensional particles, like for example in emulsions or bubbles. So muna, importante ang diameter. But most of the solid particles used in industries are not equidimensional. So therefore, it cannot be specified by a single dimension like diameter. So in that case, in order to simplify the measurement process, it is often convenient to define the particle size using the concept of equivalent spheres. So the concept, so we are to use the concept of equivalent spheres. So muna to itong gimension ganina, no? Like the equivalent diameter, kato siya. We equate either the volume or the mass of the sphere with that of the volume or the mass of the particle, something like that, and through that we can compute for the particle size. So we will adopt or we will use the concept of equivalent sphere. So in this case, the particle size is defined by the diameter of an equivalent sphere having the same property as the actual particle, such as volume or mass. So mo to, equate na to, either the volume or the mass of the particle with that of the volume or mass of the sphere. So the equivalent sphere concept works very well for regular shaped particles. However, it may not always be appropriate for irregular shaped particles. Okay, but since we are in the introductory part of particle technology, so more or less we will just focus within the kanang kuan lang siya, regular shape na particles. For irregular shape particles, it will be discussed, or rather it will be taken up in another kuan na siya, in another chapter. Okay, so we will start with the regular shape particles lang. So particles are often characterized by the second longest major dimensions. For example, say you have a needle-like particles, d sub b, or the diameter, would refer to the thickness of the particle and not the length. Okay, something like that. No? So the units used for particle size will depend on the size. Of course, no? Depends on the size of the particles. Like if the particles are coarse, then we use the units inches or or millimeters. Then for fine particles, we use the screen size. Screen size is well, it depends on the sieves that you are using. Either you are using the sieves whose mesh is this much of the in terms of millimeters, and so depende lang siya sa sieve size for fine particles. But for very fine particles, we use the unit micrometers or nanometers or microns. And for the ultra fine particles, we use the surface area per unit mass, or that is, if the surface area is in terms of meters, so and the mass is in terms of grams, so you have meters squared per gram. Okay, so depende lang unsay unit sa imong area and the unit of the mass. Okay. And then let me check. Napa ba ni siya last? Okay, I think that's the last na di. Okay. So that's the last slide for the introductory part as to what is particle technology. Let's proceed now to, wait a sec. I will, let's now proceed to particle size analysis as part of the characterization. Okay, let me share muna my screen. Okay, makita na ang akong kuan slide.
Yes, ma'am.
Okay, so let's proceed to particle size analysis as part of the characterization of particles. By the way, I'll be posting these PowerPoints na sa Moodle, ha? So you don't have to worry for the copy. Okay, for the particle size analysis, we can start, rather as what I have mentioned, we will focus most of the time using the regular shape particles. Because here, for a regular shape particle, this can be described uh, through the dimensions given, no? Like for example, kung spherical ang shape sa imong particle, usually dimension given is in terms of radius, sometimes diameter, no? Okay. Or if the shape of the particle is cubical, then we know that the cube has equal dimensions, no? Either you have the length, the width, and the thickness. So you have the side length. And then for cylinder, usually ang given kay radius and height. And then for cuboid, cuboid is similar to a rectangle. So you're given again the length, the width, and the thickness, so the three side length. Or it could be that the shape of the particle is conical or cone, no? So usually, ang given nga dimension is radius and height. Okay, so muna, sayon raw if you have a regular shaped particle, lisod kung if you have an irregular shaped particle. So we can start now with this regular particle. There are many ways of determining the particle size, no? And well, depende man god ka because there are particles that are large or coarse, and there are also particles na cute na daan, no? Very small, no? So it's hard for us to really measure, no, directly the size of the particle. So actually there are many methods of measuring the size of any shape of particle. Okay. One is through the use of microscope. So we have here what is known as the microscope analysis. So in the microscope analysis, there are common or more or less 3 to 4 common diameters na express nato using microscopic analysis. And these are the Martin's diameter, the Ferret's diameter, the Scherr diameter, and the equivalent circle diameter. So these are the different diameters na imong ma-describe if you are using the microscopic method, using microscope. Okay. So in the Martin's diameter, it refers, according to the one who discovered this, Martin, says that it refers to the length of the line which bisects the particle image. So if we just proceed to the next slide, kay na ay diagram sa next slide. Okay, here. In the above diagram, this is using Martin's diameter. Okay. You are using microscope, so when you look into the eyepiece of the microscope, diba, kani siyang circle ng himo, ni siya ang imong eyepiece, no? Okay. And then the one here, the irregular shape, no, is the particle. Okay. So through the microscope, what you're going to do is, yeah, the important thing lang if you are going to use microscope technique is dapat fixed ang orientation sa imong particle. Meaning to say nga, dili pwede nimo nga i-move or turn around, change the position of the particle. Dapat it should be fixed, no? So ang uban gali ana kay murag ilang i-dikit or i-paste ang particles sa slide, sa glass slide para di gyud siya ma-move. Okay. So manay siya. So in the first diagram, as what I have said, kani siyang circle would refer to the eyepiece, no? So inigtan-aw nimo sa microscope through the eyepiece na ano, di ba makita nimo nga circle kay circular man ang imong kuan, ang imong telescope kanha, no? And then you just move, rather the eyepiece, adjust lang nimo ang eyepiece in such a way nga it will cover most of the parts of the particle. Okay, so let us say nga mo nini iyang nakita nga most of the parts of the particle na cover, nakita niya sa eyepiece o sa microscope. So, using Martin's diameter, ang buhaton lang ana is to measure the diameter of the circle. Circle ha, dili ang particle. So, i-measure nimo ang diameter of the circle. And that diameter would refer to as Martin's diameter. So, muna to, ang diameter that will represent the diameter of the particle according to Martin. The other form is through Ferret's diameter. Yeah, if we go backward, Ferret's diameter would refer to the distance between two tangents on opposite sides of the particle. Okay. So kani siyang third diagram kang Ferret's diameter, ang gibuhat ni Ferret's kay nagkuha siya o nagdraw siya og two parallel tangent lines. So let's say mo ni siya ang two parallel tangent lines. You know what are tangent lines, no? Nga kanang intersect lang on a certain point, no? Point sa imuhang particle, okay? And then kay parallel man ang imuhang tangent lines, meaning to say they are equidistant. So the distance there would refer to the diameter according to Ferret's way, or Ferret's diameter. Okay? Then the third one, shear diameter. If we go back sa slide, shear diameter would refer to particle width, the width of the particle obtained using an image sharing device. So you're going to use a certain device here that could measure more or less the particle width, no? And then the fourth one is the equivalent circle diameter. The equivalent circle diameter would refer to the projected area diameter. Now, what do you mean by projected area diameter? Di ba fix man to ang imuhang particle no nya, dili gyud to siya pwede i-move. So kay fix ang position sa imuhang particle or stable, the position of the particle is stable there, then try to project kung unsa nga side or what angle or what side nga makita nimo sa particle. Yeah, from there you are going to more or less compute for the area, the projected area of the particle. Okay? So palanglitan, ang imong particle is cubical shape ang imong particle. Nya imong siyang ibutang no to a stable position. Nya whatever imong angle nga makita, sito it makita yun nimo ang more or less the three sides, no? The upper part of the cube, the two different sides, okay, of the cube, something like that. And then compute for the area of the particle. Yeah, with that area, you equate that area of the particle to the area of a circle. You know naman what is the formula for the area of a circle. Yeah, from there you can compute for the radius or diameter. Yeah, mo na i-refer na to nga equivalent circle diameter. Okay? So later on, doon na tayo sample problem ana. So more or less mo na siya if we are using the microscopic method of measuring the particle size. Another method is by screening or using sieving or screening na sa kung sa industry pa kay by volume naman. If sieving is used to measure the particle size, then an equivalent sphere diameter will be determined. No, naputol man. So the equivalent sphere diameter is the diameter of a sphere passing through the same sieve aperture. So the sieve aperture would refer to the holes no nga naa sa imuhang sieve sa screen, kanang mga lungag-lungag no sa imuhang screen. We call that as the sieve aperture. So whenever the particle passes through that particular sieve aperture, then of course we can say nga kay nipass siya through sieve aperture which is 1 mm, then it means nga the particle size is also equal to 1 mm kay nilusot man siya, ni pass through man siya. Kay if the particle size is more than 1 mm, then it will retain no on top of the sieve. Okay, so dili siya makalusot, something like that. Okay. The other method is by sedimentation technique or method. Okay, sedimentation, if you can still remember sa INVI, sa ES3, kaya environmental science technology, we have sedimentation technique there used in wastewater treatment, no? So your sedimentation technique or process is using gravity settling concept. So what do we do there is we just let the wastewater stay in a certain container or tank and then let the sediments or solid particles there to settle down through the pull of gravity. So mo siya no sa mo ni siya here sa sedimentation technique. So here, the particle size is expressed as a diameter of a sphere having the same sedimentation velocity under the same conditions. In the sedimentation technique or process, we use here the Stokes terminal velocity equation. I do not know if you have taken it up during momentum transfer, Stokes terminal velocity. Kung naka-remember pa mo, siya discuss na siya sa momentum transfer. And I also introduced the Stokes terminal velocity in the environmental subject, the ENVI subject. So mo gamit ta adto through Stokes terminal velocity. So from there we can measure the velocity of the particle. Okay, and then through that we can solve for the diameter of the particle size. So later on we will have a sample problem for this. So far, the sieving process or the screening process as well as the sedimentation technique or process, this will be performed in your CHE Lab 2 or Lab 1 ba to siya. Basta sure kung nga naa siya sa atong CHE lab na subjects. If only we can go there in the school, then you can physically perform the experiment on sedimentation as well as the screening. No? Kaya naman tayo kuan dito mga apparatus or devices. But sad to say nga, we are still on quarantine, so we cannot go pa. in the rather to perform the experiment. But anyway, if you want to see na naman siya yung mga videos found in the YouTube, pwede yun mong mag-search and look for videos how um, sieving process or the use of screening process functions or the use of sedimentation technique. Na siya. Okay, the next slide will rather shows us the comparisons of equivalent sphere diameters. If you try to look at the table below, okay, the first column there would refer to some sample shape of particles. So you have there the cuboid and then cylinder. So that is the shape of the sample particles. It's either cuboid siya, and the other one is cylindrical shape. Okay, the second column there would refer to um, the sphere or the particles that is passing through the sieves, no? Okay, same sieve aperture man, X sub B. So using screening process or sieving, so that the you have there the size of the sphere or the size of the particle as well, which is equal to 3. I do not know what is the unit there, but butangan na to, the value is equal to 3. Now the next column, the third column, would refer to the sphere having the same volume. Meaning to say, same volume, the same ang volume, gi-equate mo ang volume of the particle and the sphere. So from here, i-compute na nimo. You're going to compute for the diameter of the sphere. So for cuboid, you have 3.06, and then for cylindrical, you have 2.38. No? Then the next column, the fourth column, refers to the sphere having same surface area na, surface area. Okay, meaning to say nga, this time, ang imong i-equate ang surface area of the particle and the surface area of the sphere. Then from there, makompute mo ang iyang x. The x there would refer to particle diameter. So for cuboid, that is 3.83, and then for cylindrical, we have 2.74. Okay, and then the last column would refer to the sphere having the same surface area to volume ratio. So ratio between surface area and volume. Okay, so i-equate nimo ang duha ka ratio, no? Ang ratio nimo kay surface to volume. So surface to volume ratio for the particle and equate nimo sa surface to volume ratio of the sphere. Then from there you can solve for the diameter x sub SB. So the value for cuboid is 1.95, and that or the cylindrical shape particle is 1.80. Okay. So initially, you have there the dimensions of the cuboid and the cylinder. Dool ra ang uban, no? Then we now proceed to the next subtopic, which is the description of populations of particles. So we know nga there are thousands and thousands of numbers of particles. When you say bulk particles, so we need to describe the population of particles. So a population of particles is described by a particle size distribution. So we will use distribution. Frequency distribution, it's either we use the frequency distribution curve or the cumulative curves. So I think you were already exposed about frequency distribution curve and the cumulative now in your statistics. Okay, so review lang nato totong statistics. So for the differential frequency distribution, you have here the graph. Uh, says differential because what is plotted is a derivative of f, wherein f is the cumulative distribution with respect to x, wherein x is the particle size. Now, take note of the units, micrometer, and then for the df or the derivative differential is 1 over micrometer. Just take note of the units. So the derivative of f with respect to x can be also expressed as f, no, or a function of x. It, it is a function of x. So that is for the differential. The other one is pwede sad nga cumulative frequency distribution ang gamiton, wherein we plot here the frequency cumulative distribution f, no, capital F versus the particle size. Okay. And then we compute for the median or the average later on. So that's one way of describing the population of particles through these distribution curves. Okay. So kung ano ni siya, nomenclature lang niya siya. No? We use capital F for cumulative distribution. Yeah, F, the small f, which is a function of x, would refer to the frequency distribution. The distribution can either be in terms of number of particles, or it could be in terms of the surface area, or pwede sad in terms of mass or volume. But if the particle density will not vary with size, okay, meaning to say nga fixed ang density sa imong particle, then the mass distribution is more or less similar to the volume distribution. So these are just kaning nomenclature because this will be used later on sa derivation of formula. So just take note, no. So kung ang subscripts ana mo, n here would refer to the total number of particles, the s would refer to the surface area, and so on and so forth, or m for the mass. Okay. So more kuan na siya. Gamiton na later on sa derivation of equations. The next slide will show us the comparison between distributions. Diba? It's either if you want to have the distribution in terms of number of particles, or pwede sa terms of surface area, or in terms of mass or volume. So this is how their curves looks like. You're going to graph them or plot them. Okay. Then the next slide will shows us the conversion. The next slides is about the conversion between distributions. Like for example, if you want to change the distribution, let's say nag-start ka of number of particles na gusto nimo i-change into surface area or into its mass or in terms of volume, so pwede yun na siya, no? Pwede na to siyang ma-convert. So the next slides here will simply show us the derivation, no? Saan pag-convert. Okay, and then it involves some factor, say alpha. Alpha would refer to a factor. Here in the one below, alpha sub s, it refers to the factor relating the linear dimension of the particle to its surface area. So I will not discuss anymore this part lang kay ano naman siya, derivation, and ako ni siyang step by step lang, so you can follow through. So just follow through lang, ha. I will not discuss anymore this one. Says here lang as much as possible, we will avoid conversions from one distribution to another distribution. Like you have to be certain lang yun as to unsa man gyud gusto nimo na distribution in terms ba of number of particles or populations niya, number of particles, or gusto ba nimo nga your distribution should be expressed in terms of mass or in terms of volume para ma-minimize nimo ang conversion. So you have to be sure of that. Okay, then let's proceed to the next subtopic, which is describing the population by a single number. There are options, no? Whether you want the particle size of a population to be expressed in terms of mode or median or means. So balik na sa statistics, no? So review lang ni siya pod. And we know means daghan na siyang type or klase. You have the arithmetic mean, geometric, quadratic, harmonic. Okay. So just a short review lang. Mode, if you can still remember, ang mode would refer to the most frequently occurring, no, kanang pabalik-balik nga data, no. So in this case, we are referring to the size of the sample. So pabalik-balik nga value sa imuhang size of the particle. So you have there the mode. So pauna nimo ang mode. However, for the same sample, different modes would be obtained for distributions by number or surface and volume. So it has no practical significance as a measure of central tendency. So therefore, this is rarely used in practice. So seldom mas kuno na siyang gigamit ang mode method of describing the population of particle, because it cannot measure the central tendency. So ito na siyang central tendency. The central tendency would refer to the supposedly the center, no, central good. So center of distribution, kung asa supposedly the center of its distribution. But through the mode, according to them, dili siya maka determine, no, the central tendency. That's why it's seldom used. The next one, the other one is median. Well, median is more or less half, 50%, no, half of the population. Okay. So the size which splits the distribution into two equal parts, median. Since median is easily determined, it is often used. However, it has no special significance as a measure of central tendency of the particle size. So muna sad siya nga seldom sana siya use ang median. The third one is by means, through means. So according to Swarovski way back 1990, means have many different meanings. However, they can all be described by this mathematical expression: g a function of x is equal to the integral of g a function of x df, limits from 0 to 1 divided by the integral of df, taking limits from 0 to 1. But your integral of df from 0 to 1 is equal to infinity man. So therefore, the mathematical expression can be reduced simply as the integral of g a function of x df, limits from 0 to 1. We're in x here, and siyang x is the mean, and then the g is the weighting function where which is sorry naputol noon da. Sorry ha. Naputol. Let me share again. Okay, so x is the mean and g is the weighting function. So we have here the definition of the different types of means. So if your mean is arithmetic mean, then your g, a function of x, is simply x. For quadratic, it is x squared. For cubic mean, you have x cubed. For geometric mean, you have the log of x. And for harmonic mean, you have 1 over x. So muna siya ang expression sa imong g function of x depende sa type of the mean that you are going to use. Okay, then conversion naman siguro ni Sadsia. Okay, conversion of one type of mean to the other type of mean. Okay. So each mean can be shown to conserve two properties of the original population of particles. Okay, so like if, or rather like you have the arithmetic mean conserves the surface and volume of the original population. Okay, so muna iyang ma-take into consideration. If you're going to use arithmetic mean, then you have to take into consideration the surface area and the volume of the original. And then the next slides, okay, again, somewhat the way of expressing the different types of mean na siya. And then the next slide will show us the graphical form of the different types of mean. So comparison between measures of the central tendency. So the values of the different expression of central tendency can vary significantly. And if you observe from the two graphs here, you can find that there's a certain mean wherein they have the same value of the arithmetic mean, or the mean, and that is the arithmetic mean. So the means can be equated or can be equivalent, no? For example, the arithmetic mean of surface is equivalent to the harmonic mean of a volume, something like that. So, so the next slide discusses about the way of getting the equivalence, no? Equivalence, like ang mentioned nganhi, the arithmetic mean of a surface can be taken as equivalent to the harmonic mean of a volume. Yeah, how to do that is mo na siyang nganhi kanang gi-explain, no? I'm not going to discuss anymore this part. Okay, derivation man gihapon ni siya. How to equate lang. So in summary, the surface volume mean may be calculated as the arithmetic mean of the surface distribution or the harmonic mean of the volume. So kanang equivalency, no, sa imuhang mga means. Now, the practical significance of the equivalence of means is that it permits useful means to be calculated easily. Well, in terms of size particle size analysis. In the particle size analysis, yeah, we can that is like, for example, if you want to check whether the data that you obtain is good or not, then pwede din mo siyang ma-relate, no? And have the equivalency of the different means, different types of means. Now let's proceed to the next subtopic, which is common methods of displaying the size distribution. Graphical ang gihapon ni siya. Either we use the arithmetic normal distribution or the log normal distribution. So graphical way gihapon ni siya of displaying the distribution of particle sizes. So for our arithmetic normal distribution, this is how the curve looks like. Mura siya normal curve, wherein we can use the mathematical expression here that the derivative of f with respect to the particle size x is equal to 1 over the standard deviation times the square root of 2 pi times the exponential value of the expression minus x minus open parenthesis x minus x prime close parenthesis raised to the power 2 all over 2 times the standard deviation squared. Okay. Actually, kung ano siya x bar ni instead of x prime or kaning star ba, ang gigamit man gud ni Martin ngadto kay x bar, but it represents the so gani siya ni x bar, ha. Well, anyway, the average, more or less the average of the particle size there. Then the other one is using the log normal distribution. So kani siya, the left side graph, the log normal. Okay, and we use the mathematical expression, which is df over dz, wherein z is equal to the logarithmic of x. Okay, and you have here the mathematical expression. So the z there is equivalent to logarithmic of x. So either of the two, whether you use the normal or the log normal. Okay, so asalay mas preferable sa inyo, ha. Okay, then we will now proceed to some methods of particle size measurement. I will be introducing here some of the methods lang in determining the particle size, and I think we have already discussed some of this, like the sieving or the screening process. Okay, and then microscopy or using microscope, and then sedimentation, katong gi-mention ako nga we will use Stokes terminal velocity equation. So later on we will have some sample for this. And then another method is through permeametry. Permeametry, the process of this method, we will be using here packed bed device, and then we measure the change in the pressure or the pressure drop, and then from there, knowing the change in pressure or the pressure drop, we can compute for the particle size. So gamit kaya po kaning device. For the next one, electrozone sensing. For electrozone sensing, gamit ka og electrolyte, electricity, no? So here, particles are held in suspension in a diluted electrolyte which is drawn through a tiny orifice. So ipapass through nimo ang imuhang particles or the fluid to the orifice, and then doon na kay sensor uh, wherein a voltage applied across it will measure, no? So doon na kay sensor nga mo measure siya sa voltage niya kanang moto. Yeah, through that voltage reading sensor, we can calculate for the particle size. And then the last one na ko ma-share is what is known as the laser diffraction. Okay, so using light. So light is allowed to pass through certain suspension, and then once mo hit siya sa usa ka particle, then mo diffract man dayon ang light, no? And then mo to i-measure siya ang angle of diffraction, because the diffraction angle is said to be inversely proportional to the particle size. So mo lang to i-measure sayo na ni siya, pero lang you're going to use certain device, no? Of course, kay gamit man kag light. So it's called laser diffraction. These are just some of the common methods, but we know nga today we have na more sophisticated technology in measuring the particle sizes. Okay? Pwede kang research sa internet to find out what are the present technology or devices na used, no, in some company in measuring the particle size. Okay. You know that na kuan. Okay. The last slide I think here for this particular topic is kuan lang siya ruling on how to get some sampling sa imong particles. Na there are only two golden rules of sampling or getting samples. That is, the powder or the particle should be in motion when sampled. So once magkuha ko ka og sample, dapat flowing, no, ang imuhang particles. And then the whole of the moving stream should be taken for many short time increments. So doon na kay certain time increments to follow. Yeah, it should be shorter, okay, in order to have more or less a good data, no, for the sample. Okay. What time is it now? 1:13. Actually, ang third PowerPoint presentation akong ikuan is sample problems niya. I'm sorry nga, tuluran ni ka-sample problems gyud nga akong nahimo, no. I was kuan man gud nako, gi-aim unta nako nga I can give at least 4 or 5 sample problems, but then tulor gyud ang akong nahuman, sorry kayo. But you can always refer to the book by Martin Rads for additional samples, no, sample problems. Okay, I will try to to open my ato lang siyang kung ano i-discuss ka diyot para actually simple na siya nga mga sample problems. So the first sample problem, you are to calculate the equivalent volume sphere diameter, which is represented by XLV in terms, or the unit is mm or millimeters, and also the surface volume equivalent sphere, or X sub SV, whose unit is mm, of a cuboid particle whose side length is 1, 2, and 4 mm. So what this asks is to calculate the equivalent volume sphere, and then the other one is the surface volume equivalent sphere, XB and X sub SB. So what do we do first is to compute for the volume of the particle. In this case, it's a cuboid. As what I have said, a cuboid is more or less similar to a rectangle. So since given man ka 1, 2, and 4, we can compute for the volume. So 1 times 2 times 4, so you have 8 millimeters cube. And then surface area of the particle, you know how to solve for the surface area, no? Mura siya kanang isa na? The area, the total area of all the sides, no, of the cuboid. So manang times 2 siya kay doon na kay upper, lower, and then the extreme sides, and then the front and the back side, no. So man siya times 2. So if we let here 1 be the thickness, 2 as the width, and 4 as the length, then you can imagine a rectangular box, no, siya rectangular box. So you can solve for the surface area. And then we solve for the volume of the sphere. The volume of the sphere, kung sabi ito i-formula sa volume of sphere. Volume of sphere formula is 4/3 times pi times radius cube, no? Radius cube. But then you are more into the diameter man, so we express the radius in terms of diameter, so that kung i-change na to ang radius to diameter, so the volume of the sphere would be equal to 4/3 times the radius is equal to x over 2, no? Radius, 1/2 of the diameter. X there is the diameter, so x over 2. Yeah, parenthesis cube, no? So that if you are going to simplify that, you will arrive into this expression, that is x over 6 times x cubed. Okay? So the x here would refer to the diameter. So x is equivalent to 2 times the radius, no? Okay? So again, sa to ang equation sa volume of a sphere, that is 4/3 pi r cube. R is the radius. So i-express mo ang radius into diameter, which is x, and then simplify it further, and then you will arrive into this expression. So pi over 6 times x cubed, or x sub v, kay mo man ay gamit din sa problem, no? X sub v as the equivalent volume diameter, equivalent volume sphere diameter, x sub v. And then we equate. Therefore, the diameter of a sphere having a volume of 8 mm cube is, so we equate the two volumes, ang volume sa sphere o ang volume sa particle, the cuboid. So you have here the unknown, which is x sub v. So kibali ang imong equation, inig-equate nimo, so that is 8, that is equal to pi over 6 times x cubed. So your unknown there is x sub v. So that computing x sub v is equal to 2.481 mm. So the answer for the equivalent volume sphere diameter, or x sub v, is equal to 2.481 mm. Okay, so equate lang na to ang volume sa sphere of ang particle, no, in this case. And then to solve for the other one, the surface to volume ratio, okay, we can start with the particle. So kaun sa nato, no, we get the ratio of surface to volume for the particle. We know naman the surface area of the particle and the volume of the particle. So 28 over 8, or that is equal to 3.5. And the unit is mm squared over mm cube. Dili lang nato i-cancel out ha. Ang mm squared versus the mm cube. So just let it be, no? So that you will know nga it's the ratio, no, between area and volume. So wala sa particle. Next is we solve for the surface to volume ratio of the sphere. Okay, so kung man to ang surface area, ang ito na-solve ganina ang volume man to, no? Ang volume. Okay, the surface to volume ratio of a sphere is therefore equal to 6 over x sub v. Diyon sa og kuha ang 6 over x is we divide the surface area of the sphere with the volume of the sphere. So pareha sa gibuhat nato sa particle, gidivide lang ang surface area and then the volume. Okay, so the same thing here for the sphere. We divide the surface area of the sphere with the volume of the sphere. Yeah. You know naman the volume of the sphere, which is katong ganina x, or rather pi over 6 times x cubed. Mao na siya itong na-compute ganina. So, ang ato na lang i-compute ang surface area sa sphere. So, what is the formula for the surface area of a sphere? Surface area of a sphere is equal to 4 pi r squared. 4 pi r squared, or 4 times pi times radius squared. I-convert na to ang radius in terms of diameter. So it becomes 4 pi times x over 2 quantity raised to the power 2. Okay, i-simplify further, then the surface area of the sphere is equal to pi times x squared. Okay, so muna kong dimension ganina, no? 4 pi r squared. Yeah, convert the r, the radius to diameter. So diameter over 2. You squared man yung r, so you have squared. Or diameter, itong gigamit nga symbol sa diameter nga kay x man. So we have, simplifying 4 over 4, makancel out. So what is left is pi, then times diameter squared. So this is now the surface area of the sphere. So that the ratio for the surface to volume ratio of the sphere is pi x squared over pi x cubed over 6. Now, simplifying it further, then you will have 6 over x. So this is now the ratio of surface to volume for a sphere. 6 over x sub b. So we equate the two ratios. So equating the two ratios for that of the cuboid and the sphere, then you will have a value of 1.714. So equate to nimo, no, ang values sa duha. Katong 3.5 is equal to 6 over x. Okay. So that you will have 1.714. So the surface volume equivalent sphere diameter of the particle is 1.714 mm. Okay? Sige. So, nasabtan ra. Sa'yo, kung ano man siguro, no? Dali ra siguro masabtan. Anyway, ako man tong i-review lang og balik. Okay, the next sample problem is still a cuboid particle with the given dimensions, but then this time you are to calculate letter A, the volume diameter, which refer to the diameter of a sphere having the same volume as the particle. Letter B, the surface diameter, which is the diameter of a sphere having the same surface area of the particle. So sa letter A, ang volume mo yung i-equate, no? Volume of the sphere and the volume of the particle. And then for letter B, ang imong i-equate the surface area of the particle and that of the cuboid. Letter C, the surface volume diameter, or this is the diameter of a sphere having the same external surface to volume ratio as the particle. Okay, surface to volume diameter. So pareha ganina, surface to volume ratio. And then letter D, the sieve diameter. Usay sieve diameter, it refers to the width of the minimum aperture through which the particle will pass through. Nga mulusot siya, no, sa imuhang sieve. Okay? And then letter E is the projected area diameters, or it refers to the diameter of a circle having the same area as the projected area of the particle resting in a stable position. Stable position meaning to say nga, dili nimo siya pwede i-change, no, ang position, or dapat fixed siya, no, steady ang iyang position. Then from there, you try to view on a particular angle the particle, and you try to compute for the area. That area na imong ma-compute will be equated to the area of a circle. Okay? So, letter A, parihara ni sa example number 1, kuan na ni siya, the volume diameter. So what you're going to do is solve for the volume of the particle and solve for the volume of the sphere. Nya, equate mo ang duha, then you will obtain the volume diameter, which is in this case equal to 3.06 mm. So pareha rin sa example 1. Letter B, the surface area of the particle, the surface diameter, I'm sorry. So what you're going to do is to compute for the surface area of the particle and the surface area of the sphere. Na-equate mo silang duha, then you can solve na for the surface diameter. So for the particle, it is 46 mm squared. For the sphere, it is pi x squared, so that the surface diameter is 3.83. Letter C, katong ratio, no, surface area to volume. Okay. Gihapon nimo ang duha ka ratio, so you have there the answer to letter C. So the same gihapon ni siya, no, ang letter C sa katong sample number 1. And then for letter D, the smallest square, letter D, the sieve diameter, it refers to the width of the minimum aperture through which the particle can pass through. So we know the dimensions. Okay, cuboid man siya ang imong particle. So unsaon pag-pass through, or unsay iyang orientation sa imong particle, inig-pass through niya sa aperture or sa katong holes sa imong sieve, di ba? Rectangular man. So kung rectangular, kung palitan, kung mao ni siya ang imuhang cuboid, so paana siya, no? Paana ang iyang paglusot, dili paana horizontal but vertically. So, kung vertically, unsa man ni siya nga dimension nganhi sa imong particle, would it refer to the thickness or the width? It's the width, no? So, unsa gilakdon sa imong particle, ato siya mulusot sa kanang kuan. Mulusot siya sa imong sieve. So, therefore, the answer to letter D is equal to the width of the particle. So the smallest size of the sieve, the smallest width of the aperture na makapastro ang imuhang particle is therefore equal to the width of the particle. Kay paana man, no? Pa-vertical ang pag-agi, no? Pagpastro sa imong particle. So therefore, it is equal to 3 mm, the width of the particle. So sa letter D, magdepende na siya sa imong particle shape, no? Whether you have a cylindrical, a cubical, no, or conical. Kanya imong i-imagine ba kung mo na ang shape sa imong particle, unsaon niya paglusot pastro sa imong sieve. Okay? And then for letter E, sa itong letter E, projected area diameters. So what do we do is we fix the orientation of the particle. Steady lang yun ang ang position sa imong particle, and then i-project nimo ang iyang area. Unsay makita nimo nga dimensions or size sa imong, for example kani kay kuan man siya cuboid, so see to it that you can see the upper, it could be the upper or the extreme side or the front side, as well as the front side of the cuboid, no? Then from there, well, tanaw lang nimo asa ang mao gina siya ang tendency, ang upper parts sa imong cuboid, the extreme side, and then the front side, no, of the cuboid. And then from there, you solve for the area of the different sides. 3 sides man ang imong cuboid. So we say area 1, area 2, and then area 3. Okay? Then, with these areas, you equate this with the area of a circle. Yeah, so tagsa-tagsa nimo, no, like area 1, which is 3 mm, equated to the area of a circle. The equation of the area of a circle in terms of diameter is pi x squared over 4. X is the diameter. So equate lang na siya. So for the area 1, you have 3 mm is equal to pi x squared over 4. So you solve for x. And that is equal to 1.95 mm. Unit is mm, no? Kaya you're talking about diameter. And then you solve for the other two areas, area 2 and area 3. So area 2, 5 is equal to pi x squared over 4. Area 3 is 15 is equal to pi x squared over 4. So you have 4.37. Okay? So sa'yo na, no? Equate lang ka, then solve. Okay? Let's proceed to the last sample problem. For a regular cylinder of diameter 0.1 mm and length 1.0 mm particle, calculate the following diameters. So more or less, ang required or what is asked, no? For example, number 3 is more or less similar to example number 2. Kuan lang, your particle is now cylindrical ang shape niya. So what is given is the diameter as well as the length. So we do the same process in computing for answering letter A. Hindi na ako siya lang i-discuss. Anyway, pareha na siyang ang sa letter B lang kay surface area of a particle, which is a cylinder. So surface area, cylinder man, so you have two upper and the lower circles man. So 2 times the area of a circle, then plus ang body sa imong cylinder is we call it as the lateral area. Kung atong i-half ang imong cylinder, like if this is your cylinder, so you have the upper and then the lower. So circle siya, ang upper ug ang lower. So 2 times the area of a circle. Then the body of the cylinder, if you are going to cut this and open it, then you will form here kanang murag rectangular. But don't forget, yung kanisang side is the circumference of the circle. So you have the circumference of the circle, then times the height. No? The height. Okay, and so you have the area of a circle is pi r squared, and then the circumference of the circle is 2 pi r, and then express the r in terms of diameter, x, in terms of x. So change that in terms of x. And then we substitute values so that we will have 0.322 mm squared. Okay, so for the sphere, the surface area of the sphere is pi x squared man. So equate kani siyang expression to 0.3299 sakto. 0.3299. So you have 0.324 as the answer to letter B. For letter C, volume, surface area to volume ratio. So compute ang particle o ang sphere, and then equate the two ratios, then come up with the answer. And then for letter D, the minimum width of the aperture, kuan man siya, cylindrical man. So kung mao imong cylinder, so iniglusot niya paana gihapon, no? Vertical, dili siya paana. Okay, so that the minimum aperture is the diameter of the particle, which is 0.1. So the answer to letter D is 0.1. And then for letter E, cylindrical siya. So ang imong area na makita is the top, or it could be the bottom, but say the top. Anyway, they are similar, no? So the first area is the top side of the cylinder, and then area 2 is the body. Okay, so the area of the top is the area of a circle. I-equate na nimo sa area sa circle. Of course, that will be equal to 1, no? And area 2 is the body. So 0.1 times 1, or that is 0.1 mm squared. So that the projected area is for area 1, okay, that is 0.1. For area 2, it's 0.35. Okay. Okay, so I think that's all. Kay tulo ra gyud akong nahuman og himo. Sorry jud kayo. But then you can always refer to the book by Martin Oratz for additional samples. Muna akong ganahan sa kang Martin Oratz, no, kay daghan kay siya sample problems. And then after that, na siya mga exercises. So you can always do your part, no. If you really want to learn, makakaton jud ka through his book, no. Nya sayon sad siya i-understand ang iyang explanation. Kaso lang it's quite old. Okay, but as what I have said, the concept is the same, or the principles behind it's the same. What changes lang siguro in terms of revisions or kanang kuan, mga sample or applications, no? Okay, so far, time check is 1:39. So far, do you have any questions or might be some clarifications? Medyo dugay-dugay yun, no? Kay taas-taas ang atong presentation. As what I have said, I will be posting the 3 PowerPoint that I showed to you today. So if you want to review again, pwede ato sa Moodle. Okay? And then I might be posting also some assignments for you to answer, but then I was thinking man sagod nga anyway naamang gyud tay laboratory component, then might be ako na lang ihatag as problem set para you have more time to study pa, and then once if you have gathered enough knowledge to a particular topic, then you can answer the problem set. Okay? Sige. So, before we go, mag-release sa ko og attendance list. Di na lang ta mag-picture. Magkuha na lang ko. Attendance list. Okay na. So, if you have no questions, then I think we will call this a day. Thank you for attending. And bye-bye for now.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am. Yan, yan. Thank
Welcome.
you.
Okay, so i-check lang ko niya inyong Moodle ha, kaya ako ni siyang i-post dito. Sige,
Okay,
bye-bye.
ma'am.
Bye, ma'am.
Bye-bye.
Bye, ma'am.
Bye, ma'am.
Bye.
Bye, ma'am.
Bye.